Okay, hi. Welcome to our next tutorial. A little more meaningful lifecycle cost evaluation here. When I say meaningful, I mean a little more meat on the bones in respect to what actually happens. Over the last number of tutorials, I've been showing you the calculations, and I've been showing you maybe those calculations for a couple or a number of lifecycle costing items. But here we can see the calculation of facilities management costs. Now there is only 6 or 7 costs in there. There could be a whole lot more, but at least it gives you an idea as to how you might calculate these items. These ones, as in the exercise 4FM, facilities management, are yearly costs. So facilities management costs that would occur on a yearly basis. And then I have another sheet for costs that occur at irregular intervals, and they may be replacement costs or repair costs, planned preventive maintenance, that occur, every 5 years, every 10 years, depending on what you need to do and I suppose the service life duration of those particular items. Starting off with the facilities management costs, you can see in the top left hand corner here we have real costs. A little bit further down with the nominal costs, which are our future costs or forecast costs, with the escalation rate accounted for, and then we got our PV, or discounted present value. So we want to calculate the total nominal costs and the total present value, and of course the total base costs or real costs for those items. Again, we're going to do a little bit more detailed analysis here. We've got a similar kind of setup to what you see in a cost plan or bill of quantities. We've got a unit rate, quantity unit and rate. So if we got cleaning 1500 meters squared at a certain rate, that's going to be our cost. Same goes for building and asset maintenance, waste management. Now it doesn't necessarily have to be a cost per meter squared. It could be a cost per lump sum, cost per item, cost per meter cubed, cost per unit, just like you'd see again in a cost plan. So quantity times rate equals cost. Now that could be a weekly cost, it could be a daily cost, it could be the cost within a year. So we want to calculate what the yearly total is. And if it's a cost per week, we multiply by 52 in terms of a number of occurrence. If it's a cost per year already, we leave it at 1. If it's cost per day, 365, etc. So I can see there, if I double click the cost, quantity by rate equals cost. And then if I double click the yearly total, calculations are already in there, and that is number of occurrences times the cost. So that first item, we've got cleaning 1500 meters squared at a rate of 35 cents a meter squared. Cost per week is 525, multiplied by 52 to get our yearly total. We don't have to do the same on the next item because it's already a yearly cost. Okay, so what is and how do we input all that information on a yearly basis? Well, we could physically type it in from year to year and from item to item. It'll take us a little bit of time, but as I showed you before, you can use the kind of power of Excel, so to speak, to do this quickly. So I'd start by, again, every time I use a formula, click equals and click that first item. So that would be the first item, and again I could go equals, keep clicking from I suppose year to year to get each one of those items, which are exactly the same on a real basis in today's money from year to year. But as I said, why would I do that when Excel has a way of doing it for me? So I'm going to click equals and then click the total. Now what I want this to do, I don't want to lock the cell, because if I lock that cell and fill across and fill down, it'll fill in 27,300 into every item. I just want 27,300 in this particular row for cleaning, and then I want it to move down to 27,750 for the next row and 11,700 for the next row, etc. So in doing so, I need to lock the column, but not the row. So it'll lock to that column, but it'll let the totals move down from row to row. So in doing so, I've got I5, which I clicked, and I want to put a little dollar in front of the I. So Shift 4. So $I, and do not put the dollar in front of 5 because it'll lock that cell. Whereas I don't want it to do that. I just want it to lock the column, which is the first, I suppose, letter. So click return. Now if I pull that across with a little right click, or sorry, it's left click, but it's the right little dot, that's the right bottom dot there, pull it all the way across, keep going to year 28 and release. And then if I leave that highlighted and pull the bottom right hand corner down by left clicking, holding down the left mouse click and release. And there I should have the exact same items in every column on a yearly basis. So from a total point of view, let's total it, equals sum, and fill down, hit return. Do the same for each one, or fill all the way across, or copy paste all the way across. Again, using this little crosshair, which is real handy functionality in Excel. I'm going to pull that all the way across and it'll fill that formula from item to item and release. So it should be the exact same from year to year, because we're calculating it in real costs, and in doing so it's today's money for every year, so to speak. So let's calculate a total for those 28 years for each item. So that would be in each row equals the sum of, and then all the way across that particular row, and release at 28. So hit return, and then we're going to do the same. In fact, if I pull that down, it should work, and I think it does. So double click to check one, yep, and then total. And hit return. Maybe give these a little comma separator to show that they're numbers, and we've got a significant sum of money there over 20 years in terms of facilities management costs, €4,113,760. Continuing on from that, we got to calculate our nominal costs, so our future forecast costs, accounting for escalation. So a couple of different factors here are different escalation rates. One for normal escalation, which would include construction materials and services. And then I have a different one for escalation of energy. So energy is slightly increasing at a bigger rate than normal escalation, which can be the fact, be it our gas or electricity seems to be priced or increasing at a higher price than normal goods and services. So we're accounting for that here. Might start with the normal escalation factor, or at least the goods and services escalation factor at 2.5% first. So let's calculate that. Again, if you can remember the formula, there's a couple of different formulas to the power formula, or to the normal 1 plus the rate to the power of n being the time, or being the year. So let's use that. Equals, I believe it's open brackets if I can remember, 1 plus, click on the escalation rate of 2.5%, close the brackets, and then multiply by not multiply by, that's a mistake, to the factor of, and then click 1. Okay, so we need to do a couple of things here. Let's lock that cell. Let's lock the I-15 by highlighting it up here and pressing F4. So $I, $15, and multiply by row K18. And we'll leave that as is, because that should pull across as we go from item to item. So if we click return, now if you need to increase or decrease the decimal points there, do so. It's pretty obvious that it should be 1.025 because it's 2.5% on the factor of 1 at the end of the year. So as I pull that across, it should increase, multiply every factor by 2.5% on a year-to-year basis as we go across, and release. We're left with 1.9965. So that's our factor, our factors for our escalation of construction goods and services. Let's do the same for E lower E, which is E lower energy, E lower M being E lower materials. I might even copy that formula, copy, and paste. Okay, now a double click just to make sure. That has went down one. Well, let's pull it up or change it to K18 rather than K19. And it is locked at that cell, but I'm going to lock it, pull it up. How do I do that? I just hover over the outside, and there now, rather than having to type it in, I just moved around the cells by using the color kind of borders here, hovering over them, moving them up and down. So I can see that that's probably right. 1 plus I14 to the log, in terms of that cell, to the power of K18. So if I hit return, that should be 1.0367, and it is, because it's 1 unit the first year multiplied by that first percentage in terms of escalation. So pull that across, and that should be going up at a further rate than the previous factor. So I kind of leave this to yourselves, but maybe start you off. So the first item there is cleaning. What do I want to do? I want to equals and go up to cleaning, hit it, and then multiply that item by cleaning would be goods and services, so it would be E lower M. So the first item there, and hit return. Now I want to possibly lock that row 15, because I don't want it when I pull it down to move to this row. We'll get to why that is in a second, because it would move on to that factor. But to lock that row, which is K15, I'm going to put a little dollar in front of the 15. So it's almost the opposite of what I did up here where I locked the column. So K5, I'll let that float because I want that to move from item to item and down. Also in terms of column, from item to item. So I'll let both the row and the column float. And this one I'll lock the row because I don't want it to move down in terms of down the columns in terms of the cells. Okay, so let's try that. Sometimes you can make a mistake. You can figure out that you have made a mistake by locking the wrong column or row, or locking either one when you should lock the other. And you might have to go back, which is no big deal. So that makes sense. It's that multiplied by that is that. Now if I pull it across, I can see that each item is moving across with it. So go all the way across and hit release as you pull it across. And what you can also do then is, let's even check one. So that by that item. What you can also do then is, hopefully, let's check this. As I pull that across there, okay, and then all that row is highlighted as a kind of complete row, and then I got my little check grid item here, bottom right hand corner, and pull that down, and hopefully it would have escalated based on what row I've locked to each respective item. So let's just double click one of them to check. So in this particular column, it would be this particular factor. This is grounds maintenance, so it should be multiplying by grounds maintenance, and it is. So that's all good and well, but remember, we've got energy and utility costs. That isn't multiplied by a factor of, let's say in the first column, 1.025, it's multiplied by a factor of 1.0367. So that one column, that one row, we need to change. So let's double click that. And let's just leave everything as is, but pull down that E lower M factor, material, goods and services. Just hover over it, push on your left kick button, release. Pull it down and release. So now you've changed it to that. And obviously you need to do the same for each one of those items across that row. So release. All right, and maybe just to signify that it's different, you could give it an italics, or maybe give it a color. Same as what's going up here. Total each row. Get your totals for each item per row, and get your total escalated costs. Then, and I want you to do this yourselves, then go down to your present value. Present value will be a little bit easier. You'll put in your present factor formula. You've just got one rate. You don't have to split rates in terms of escalation like you did there into two. It's just one that will apply to all. And then you'll apply it to the nominal cost. You'll apply it to the escalated costs. Students make mistakes sometimes. They apply their discount to the real costs. The logic of that, of course, is what we went through in class. You have your real costs or your base costs, today's money. You escalate it to your forecast costs, and then you discount those forecast costs. Now you can, as I said before, do them in one calculation, We're showing that step-by-step process because we might want to show our client both nominal costs and both escalated nominal costs and present value costs. Whereas if you're doing it in one calculation, you don't get to see your escalated costs because it's included in the actual real discount rate. Probably confusing you there, but you understand the logic of the steps, which is the most important thing. And now we're applying it to a kind of a real world scenario. Okay, so we'll move on from that now to exercise 4, the replacement based on our cost plans, replacement items. Okay, moving on to replacement costs. These are calculated differently because they're not yearly costs occurring in a uniform basis over each year and then escalated and discounted in a uniform process. They're irregular costs, so they do treat it a little bit differently. Now these are would be replacement costs and repair costs. You can see there on an item by item basis, they're occurring at irregular intervals over a certain study period. So we got using 28 years again. So within that 28 years, we've got replacement of roof coverings. So that would be year 10 replaced, year 20 replaced, and year 30 replaced. But of course, if year 30, which it is outside our 28 year study period, we won't be replacing in year 30 because it's outside that period. So year 12, year 24, and then that's our last replacement of that item, because again the next item or the next replacement is outside the study period, and so on and so on. The windows will be just replaced once within the study period, same with the internal walls and partitions. So that's the logic. Now what we can do, we've got what you would see in a cost plan. We've got a quantity unit rate, and we've got an uplift factor. Now the uplift factor is essentially an allowance for the demolition of the existing item when that item gets replaced. So obviously if we're putting a new item in or the same item in again, we have to take out the existing item, and that's an additional 10% as opposed to installing it for the first time on a concrete floor that is prepped for you. So that's what that uplift factor is. So you'll see that last item there, quantity unit rate cost uplift, and it's all just 10%. Could be different from item to item depending on what it is, but let's just go with 10% on each item for the moment. And then that last item there in this series of columns is our factored cost, and that's essentially our uplift multiplied by our cost. Okay, so as I said, let's deal with this first item, and once we can do that, we can apply the same scenario to each row. This first scenario is getting replaced in year 10. I could scroll across to year 10 and type in that number, that factored cost, do the same for year 20, and then I wouldn't have it again because it's outside the 28 year period. And we can do the same then for each row, each relevant row. But again, as I said before, if you can use the functionality of Excel to do it quicker, do so. I'm going to show you a little tricky formula to put in here using a divisor formula, an if scenario and a divisor formula. I know this might sound a little bit difficult, but once you've done this once, like every calculation in life cycle costing, you can use them time and time again. So when you're setting up a life cycle cost exercise, it's always the first time you do it, the first time you do the calculations, that's the difficult part. But once they're done forever, and you can use those calculations again from job to job, just using it as a template. It doesn't really matter whether it's a detailed life cycle cost exercise or where it's a more broad calculation on a component level based on possibly the example I showed you before, rainwater harvesting system. The calculations are the same, either whether you're doing one item or 100 items. The calculation of that one item is the same. You're just kind of applying it across the board. Now this is very similar to what we did in the facilities management. Once we got the irregular costs set up, I suppose in a kind of a cash flow analysis, we're applying it then to our nominal costs, and then we're applying present value discounted costs to those nominal costs. Nominal costs being escalated costs, present value being discounted costs. Again, don't get confused too much with the terminology. You'll hear different terminology based on what book you're looking at or possibly what paper you're looking at. Base and real costs tend to be today's money. Nominal costs and escalated costs are forecast costs in the future in an escalated I suppose scenario, and then present value costs are the discounted costs. So that's the kind of equation in terms of the time value of money. Okay, so let's look at this. Hopefully I'll get it right. So let's delete what's there and try and put a little bit of logic on this. So I think I have got the explanation of this open if I just click my internet browser. Okay, so what does this mod function do? The Excel or the Microsoft Excel mod function returns the remainder of a number is divided by a divisor. So if some 10 is divided by 10, you get 0. So it doesn't return a number. If 10 is divided by, I suppose, 20, you get 2. But that's, I suppose, that's a logical division. So again, you don't get a kind of a remainder as such there, or a fraction. So let's just go back to our functionality here. Okay, so let's apply that to this first, I suppose, first column. And let's do it in such a way that I can pull it across and pull it down like I've done in the past. So equals, again, hopefully I'll get this right. If, so I'm using the if scenario, if this MOD functionality, the logical test, MOD open brackets. So if the number, let's say the number 1, that first year, is divided by 10, okay, close brackets, equals 0. Okay, so that's the test. If 10 divided by 1 equals 0, it returns a value of 0, that's my true value. Okay, so then what I need to do is comma. So what's the truth? Return J9. Okay, so if 10 divided by that returns a 0, put in the actual factor replacement costs. If it doesn't, put in 0. Okay, so I suppose close brackets. So I suppose the logic of that is if that was 10 and it was divided by 10, it would return a 0 or a value of 0, and thus you'd put that true value in. It would return that true value. If it's not, it'll put 0 in the cell. So this one, logically, 10 divided by 1 is going to give us a weird calculation, or an error, or a divisor, or a remainder, a fraction of a divisor. It's not going to be, it's going to be false, so you'll put 0 in there. So only when it's an integer, this calculation basically base the calculation on if the 10 is a divisor, an integer of the number across the top, so whether it's a 10 or a 20 or 30, then you'll put in that calculation. That's the logic behind this. Now I'm going to have to lock a couple of rows and cells here to make sure that when I do pull it across and pull it down, that it works. So in front of 2 there, I'm going to put in my little dollar. So I want to lock the row, dollar. In front of the column here, D9, I want this column to stay the same. I don't want it to pull across from column to column. I'm going to put in the little dollar. And then in front of J, I'm going to do the same thing. Put a little dollar in. Where's my dollar again? So also J, I want that column to lock. Otherwise, when I pull that across, it'll pull to the next column and it won't work. So let's hit return, see what happens. It returns 0. Now you won't see 0 because I've got this little optional functionality up here. Clicked that if there's a 0 in the cell, make it blank. I think I've showed you that before. If not, actually I might show it to you again. So just to do that, you can click File, down to Options, I believe, Advanced, and scroll down here. You'll probably see it unchecked. I always find it difficult finding this thing. Okay, so uncheck that box there. Show a 0 in cells that have a 0 value. The reason in a cash flow analysis I don't loads of zeros in there. So if there's a 0, it's going to return a blank. So I'm going to click OK. All right, well, let's try this. Pull that all the way across. Release. So there we go. In year 20, I have that number. In year 10, I have that number. Okay, now let's highlight it again. And hopefully, depending on what lock I have in a row, what lock I have in a column, it'll all work. Pull down and then stop at the very end. All right. Now, I've got a load of divisors there. What I need to do with that is I need to delete them. So I'm going to just highlight the deletions. Now, that's because I've got formulas in there and they're applying to blank rows. So let's just get rid of those. 2 blank rows there. Sorry, bear with me. And then my last, I suppose, error there, delete. So what we have there is a fairly logical cash flow forecast based on the calculation of one formula I did in there. If I just come back, I can see if I clicked any one of those cells that it should be applying the right scenario based on that little, well, I suppose it could be seen as a bit of a complex calculation because it's got two functions in there, an if function and a MOD function. But hopefully you follow that. Again, it's a bit advanced. If you didn't, don't worry too much about it. Maybe somewhere down the line you'll develop that if you do advanced Excel training. You might develop that skill. I didn't do advanced Excel training myself. I just kind of picked this up by Googling different things and working out and trying to test them and trying to figure them out. So once you've that done, as you can see, different items happen at different times. What would have returned a 0 is shown as blank based on what I did up there at the file. And what you're going to do is you're going to apply the exact same scenario you did before in other calculations by calculating your I suppose your escalation factor, by calculating your pre-V factor, and by linking it up there to the cells. Again, if it calculates a 0 or if there's a cell blank, it should return a blank. So go ahead and give that a go. Okay, so let's look at the solution to this. So the first item here, the replacement costs, is our base costs, and that is just essentially putting in today's money. What are the cash flows from item to item, from row to row, and using that little bit of a formula there, we are able to automate that process. But again, you don't have to use that. It's just something that if you do once, you can use time and time again, and it's a good way of kind of intelligently telling Excel how to separate cash flows based on yearly costs. So irregular costs, it's worthwhile remembering that or trying to figure it out based on what I've done in the class and the tutorial, and keeping it in mind for other cash flows and not just life cycle cost exercises. So once you've done that, you'll do in the exact same way that you've done before the escalated nominal costs. So again, calculate your factor and pull them across, and then link your factor. If I click one of these cells, link your factor and multiply it by its corresponding real costs. Do the same then for your escalation factors. Again, in this, or sorry, your discount factors. Calculate those based on the discount rate or the present value rate, and then get your corresponding cell to cell. Double click one item here just to see. So that particular factor in year 8 multiplied by its corresponding item, painting in the nominal costs. So there it is there, painting in present value. So that should all total up. You can see that your present value calculation is a bit less, or a good bit less, than your real costs, and that is due to the difference in I suppose the discount rate and the escalation rate. Because the discount rate is significantly more than our escalation rate, we're going to have a present value that is less than our real costs. So that's the logic behind that, which I explained before. Going back to the first exercise, that's it, finished there. Again, we've done as far as the different escalation factors. We applied that to the nominal costs, and then just like we did in the replacement costs, we're assigning or applying those factors to their corresponding nominal costs. So let's just come down here and finish it out. So we've got a little, I suppose, chart that we want to produce here. The first item are facilities management costs in terms of real costs. I'm going to click equals and click the actual cost there, the 4 million odd. Then in nominal costs, it's 6 million or so, and then in present value, it's 2.8 million. Then we're going to add a replacement, equals, click the replacement, go up to, no, it's already there, go to our real costs, click that, then click the next item, which is our nominal cost for replacing items, click the sheet, and then click the cell. Then go back, again, equals to open a formula, click the sheet, and then the last item here is our present value. So the totals are already calculated there for each item. Total real costs for both replacement and FM costs is 5.5 million, 8.7 million, 3.6 million. Now logically, if I change any one item here, because of my links, because of the intelligence that I've set up in Excel, and from sheet to sheet, it should change what's going on here. So for example, if I see that my real costs are 5.5 million, 8.72, and I just change one item here, let's change grounds maintenance, or something that's a little bit more, change that to 5,000 meters squared. I'll change that, just bring that across. We'll change this item, we'll change this item. Now, if I come down here, it's changed all those across, which makes sense. So it's applied all the calculations to that new item. Now, I'm not going to do that, so I've gone back a couple of steps. What I do want to show, that was just to show you that changing one item should proliferate through the calculations once you've it set up correctly. What I'm going to do now is I am going to show you a little chart. So let's highlight the series of data that we want to chart. Now I could highlight the totals as well, but I'm not. So those items. Go to insert, and the type of chart I want to insert is this cumulative chart. So click that, and then pull it down below the line item, and scroll down a little bit, and maybe increase the size of this thing. Okay, so there we have our real costs, our nominal costs, and our present value. You can see that the majority of costs are in the blue items here, which is our FM costs. Our replacement costs don't really account as a proportion, maybe 20-30%, even less of each one of those items. Our real costs, or at least our present value costs, as I said before, are less than our real costs, because of that differential between the escalation rate and the discount rate. If that was flipped, as in we had a greater escalating rate to discount rate, the present value cost would be higher than the real costs. So you can play around with that once it's constructed. Once you've got your Excel spreadsheet constructed like we do here, you can play around with variable testing, change quantities, change rates, change the actual rates of the energy costs and discount factors. Just remember though, if you are changing, for example, your escalation rate for 3%, do so there, but also do so consistently do so in your replacement costs. So that 2.5 would change to, as I said, 3%, and that in turn then would change these items down here. So you can see that these numbers have changed. This chart has changed. Again, as I said, I don't necessarily want to do that, so I've gone back a couple of steps and left it as is. So that's a tutorial. And that is getting into a little more detail in our life cycle cost exercise. We may just have one more, but that is, if you can do this, these two exercises in terms of FM and replacement, I think you can pretty much do any life cycle cost exercise. It's just a matter of trying to get the data and formulate it in such a way that it makes it presentable. You don't have to do it in this way. You'll see that other templates I might give you, or exercises that I might give you, do it in a different way. That's the thing about Excel. That's the thing about life cycle costing. No two individuals put it in the exact same format. The calculations should be similar. I might even put together a summary page and roll those total costs into a summary page. But once you've got the calculations down, you can pretty much do it and present it whatever way you want. This isn't necessarily in the ISO 15685-5, but again, if I was to put different categorical structure or work breakdown structures on these items, I'd be putting them into different codes, which isn't a big deal either, and I might show you that at a future date to put it in line with the ISO standard, or maybe even the ICMS standard. So I hope you've enjoyed this particular lecture. I think if you can do those, you're on the course to being able to do life cycle cost exercises. Thanks very much.